Hi, this is Mr. Ward, and this is going to be a video on the basics of exponents. So exponents are uh, basically a little notation that modifies a number to tell you how many times you're going to use it as a factor. So I'm going to actually switch screens over here to the basics of exponents because there's a nice little diagram on here. Take a little tour of it. Um, so an exponent simply tells you how many times to use a number as a factor. And here's a nice little example of it, 2 to the third power. And what this tells us is that we're going to take this number 2, which is called a base, and that's the language you'll need to know, and we're going to use it as a factor 3 times. And so here's the exponential form, 2, we say 2 to the third, um, and or you could say 2 cubed in this case, since it's a third power, and cubes are three-dimensional. That's why we associate cubed with third power. And here's expanded form. It just takes the factors, says 2 times 2 times 2, and standard form is when you've uh, simplified it or evaluated this expression into a number. And we simply have 8. So 2 to the third equals 8. We will be getting into exponents that are negative and zero and even fractions and decimals. But in this first level, it's simply about exponents that are whole numbers. And a whole number are really natural numbers. Natural numbers are the counting numbers that go from 1 up. So an exponent of 2 to the first would be 1 factor of 2, 2 to the fifth would be 5 factors of 2, and so forth. So these are going to be particularly useful for manipulating big and small calculations, of course. But let me actually go into Desmos because I think that'll uh, help clarify some things. So uh, let's say 10 to the third power, and notice that it equals 1,000. That's 10 times 10 times 10. I've expanded it, and the standard form is 1,000. I'm going to do another example. I don't have to use a whole number as my base. I could use a fraction as my base. So I could say 2/3. And in Desmos, what you do to get to the exponent is you, uh, right next to the number, you say Shift 6, and that lifts you up into a superscript space, which will allow you to put the exponent in here. So I'm going to say 2 to the third. No, not 2. No, I'm sorry, 2/3, and I'm going to make that to the fourth power. Okay. Now, sometimes it's useful to put it inside parentheses just to make it clear that we're raising 2 to the 2/3 to the fourth power. And what this means is I'm going to say 2/3 times 2/3 times 2/3 times 2/3. And I get this decimal, but don't pay much attention to that for right now. Notice that it's 2 times 2 times 2 times 2 here, and 3 times 3 times 3. So this 2/3 to the fourth power could also be written as this: 2 to the fourth over 3 to the fourth. And I get, oh, I didn't write a 4, I wrote a 3 there. And I get the same decimal. All right. Now, and I could also expand that just in the numerator. So I would have 2 times 2 times 2 times 2 all over 3 times 3 times 3 times 3. And that 3 times 3 times 3 times 3 becomes 9 times 9, which is 81. And the 2 times 2 times 2 times 2 becomes 4 times 4, or 16. And that is what that equals. So when we're dealing with exponents, we're going to be thinking in terms of timesy thinking. We are repeatedly multiplying, and later on, you'll see how it's also repeatedly dividing. I'm going to do one more example, and this is an important distinction. What do we do when the base is negative? How do we communicate that? So actually, I'm going to do that in a really short second video.